Good morning, everyone. We are here today to talk about an important topic, the Kumi unit, and its use in hydraulic activated systems. I will be guiding you through how this device works and how it is used in a variety of applications. Let's get started. An accumulator, also known as a Kumi unit, is utilized in numerous applications to provide power for hydraulic activated systems. It involves multiple high-pressure cylinders filled with gas, usually in bladder form and hydraulic fluid or water under pressure. All these components work in tandem to deliver the required power for rams, BOP, annular, BOP, and HCR. In addition to other hydraulic equipment, this schematic illustrates the BOP control unit system. At the top is the pump used to pressurize the system. To the right of that is the unload solenoid valve to direct fluid to the tank. The rest of the elements are made up of the inlet solenoid valve, the check valve, the relief valve, and the bleed valve, all situated to the left. Next, the pressure regulator and the accumulator pressure gauge are on the right side of the schematic. The pressure transmitter for the accumulator, the pressure transmitter for the annular preventer, and the pressure regulator are all on the left side. At the bottom, the plug port test outlet, the rig test outlet, and the relay outlet valves appear. Finally, the electric power supply is located in the middle. A Kumi unit, commonly referred to as an accumulator, is essential for providing hydraulic power to the BOP stack in order to open or close it. It contains several high-pressure cylinders filled with gas or hydraulic fluid, which are used to store pressure for hydraulic activated systems. The reservoir tank must meet the APIR P53 standard and must have a total capacity at least double the required volume for securely closing all BOP equipment. Apart from that, the pressure in the manifold, accumulator, air rig, and annular preventer must all be monitored and controlled on the BOP remote panel. The pressure for a 3000 CSI surface stack system should be kept within the designated range of +1 500 CSE 3000, TSI 500, 1 500 sect, and 130 PSI respectively. The Kumi unit is composed of four main parts: accumulators, pumping system, manifold system, and reservoir tank. As per APR P53, 2 or 3 independent power sources are usually used to fuel each closing unit. Potential sources can be hydraulic pressure stored in the bottle's pneumatic or electrical power. The diagram below illustrates how the accumulator is lined up for the surface stack. This configuration guarantees the necessary levels of power to keep the Kumi unit running at optimal efficiency. The pressure regulator installed in the Kumi unit is essential for the right functioning of the rams, BOP, annular, BOP, HCR, and other hydraulic equipment. It maintains the pressure of the annular side and manifold at 500 to 1 500 CSI respectively. Additionally, it is fitted with a blue line and a red line that control and maintain the pressure for systems like VBR's blind shear, rams, annular, and HER. This helps the system to run smoothly with minimal risk of failure. The accumulator or Kumi unit is a common tool used in hydraulic activated systems. It is comprised of several high-pressure cylinders that store gas, usually nitrogen, and hydraulic fluid or water under pressure. The system works like this. The accumulator bottles are each fitted with a rubber bladder that is pre-charged with nitrogen at 1000 CI. This is then pressured up to a minimum operating pressure of 200 CI with 1.7 gallons of hydraulic fluid. From there, the bottles are pressurized up to 3000 CI with an additional 5 gallons of hydraulic fluid. This 5 gallons of hydraulic fluid is referred to as the usable fluid. By utilizing Boyle's law, the usable fluid can be calculated. An electric pump and 2 pneumatic pumps are used in the Kumi accumulator unit in order to ensure a pressure of 3000 psi in the bottle. When the pressure dips below the specified level, the electric pump will switch on and draw hydraulic fluid from the reservoir tank to increase the pressure. Additionally, the pneumatic pumps can be used to either assist the electric pump or promptly raise the pressure in the bottle. This slide contains information about the storage and regulation of hydraulic pressure in the Kumi unit. It is important that this pressure is maintained at 3000 CI, and 2 pressure regulators are included to ensure this. The manifold pressure should be kept at 1500 CI. The blue line is for opening, and the red line is for closing the various equipment such as the Vers blind shear rams and annulars. The fluid direction is controlled using a 4-way valve. The Kumi unit is engineered for providing hydraulic pressure through storing either gas or hydraulic fluid in large pressure cylinders. It has 2 distinct pathways for controlling the output pressure. The first is for controlling an annular preventer, the pressure of which is initially as high as 3000 psi, then reduced to a maximum of 1500 psi. This is done to make sure the rubber seal within the annular preventer is not damaged due to the high pressure. The second pathway is designed for rams preventers, blind shear rams, pipe rams, and HCR valves. The pressure is lowered to 1500 psi and is then distributed across the manifold system referred to as manifold pressure to activate all pressure. Activated equipment. This PowerPoint slide deals with the components and recommendations of a blowout preventer, BOP, control system. Bulb control systems can be found on drilling rigs and are used for controlling well kicks and preventing blowouts during drilling operations. It is a closed-loop design, meaning 2 lines are needed for all pressure-open pressure, close BOP stack functions. The operating fluid is mainly petroleum-based due to its capacity to operate at high pressures. However, as a result of the potential for ecological incidents if a system leak occurs, many offshore contractors are exploring other eco-friendly alternatives. The Kumi accumulator is one such solution, and this presentation focuses on its mechanism. To be compliant with APRP 16, an offshore rig system must include electric remote control panels. This is due to higher safety requirements for offshore rigs, as these panels allow for a system to be operated from a distance, enhancing safety. Operators must check that their system has the appropriate standards and that all its components are of high quality, tested and maintained correctly. Check the components for an accumulator, Kumi unit. The customer air supply should have normal air pressure of 125 psi. Air pumps require higher air pressure and air regulator may be necessary. Air lubricator is connected to the air inlet line of air. Operated pumps and requires Psi 10 lubricating oil. A bypass valve is connected to automatic hydro. Pneumatic pressure switch, which should only be opened for pressures higher than 3000 CI. The pressure switch is typically set at 2900 CI with air and electric pumps, and 3000 CI with air pumps alone, which can be adjusted with spring tension control. Air shut. Off valves are manually operated to control the air supply to air. Operated hydraulic pumps and should be opened or closed accordingly. For no. 88,550 pumps, the normal operating air pressure is 125 CI with a maximum of 200 CI. For no. 88,660 pumps, the normal operating air pressure is 125 CI. The suction shut off valve is manually operated and should be normally kept open. A suction strainer is needed for each air-operated hydraulic pump suction line. The suction strainer is located in the suction line of a triplex or duplex pump and filters out debris and dirt. The check valve is on the delivery line of the pump and prevents backflow of fluid. The accumulator shut off valve is manually operated and should generally be in the open position when the Kumi unit is in use. Nitrogen precharge in the BOP accumulator system should be checked every 30 days as other gases and air can lead to fire and/or explosion. The accumulator relief valve is set at 500 CSI and used in emergencies. The fluid strainer is located on the inlet side of the pressure reducing and regulating valves and should be cleaned every 30 days. The pressure-reducing and regulating valve should also be manually operated and adjusted according to the specifications of the ram. Type BOPs. The main valve header has a working pressure of 5000 C and a 2-inch all-welded connection. Lastly, the 4-way valves have air cylinder operators for Kumi unit is an integral part of hydraulic apparatus, including rams BOP annular, BOP HCR, and other equipment. It consists of several high-pressure cylinders storing gas in bladders and hydraulic fluid or water under pressure for hydraulic activated systems. To manage and control these cylinders, the unit is installed with a manual 3-way valve, a pressure-reducing and regulating valve, and a selection of gauges and transmitters. The manual 3-way valve can be employed to apply pilot air pressure to the pressure-reducing and regulating valve from either the air regulator on the unit or from the air regulator on the remote control panel. The pressure-reducing and regulating valve is designed to reduce accumulator pressure to the required annular BOP operating pressure. To monitor and measure the pressure, the Kumi unit is kitted out with an accumulator pressure gauge, manifold pressure gauge, annular preventer pressure gauge, and 3 pneumatic pressure transmitters for the accumulator manifold and annular preventer pressures. Additionally, the unit is supplied with an air filter, 3 air regulators, and an air regulator for the pneumatic pressure transmitter for the annular pressure. The accumulator unit design and part list includes, but is not limited to, the following components: 40. A rig test check valve. 41. A hydraulic fluid fill port. 42. An inspection plug port. 43. A rig test outlet isolator valve, which is manually operated. 44. A rig test relief valve that is set to relieve at 6,500 psi. 45. A rig test pressure gauge. 46. A rig skid outlet and valve header isolator valve, both manually operated. 47. A rig skid relief valve set to relieve at 2,500 psi. 48. A rig skid pressure gauge. 49. Accumulator bank isolator valves, which are manually operated and normally open. 50. The rig skid return. 51. The rig skid outlet. 52. Electrical power. And 53. The rig test outlet. The accumulator unit is a complex piece of machinery designed to hydraulically operate rams BOP annular, BOP HCR, and other hydraulic systems. It stores gas, hydraulic fluid, or water under pressure and can be operated manually to control the pressure in the unit. The components of the unit include a rig test check valve, a hydraulic fluid fill port, an inspection plug port, a rig test outlet isolator valve, a rig test relief valve set to relieve at 6,500 psi, a rig test pressure gauge, a rig skid outlet and valve header isolator valve, a rig skid relief valve set to relieve at 2,500 psi, a rig skid pressure gauge accumulator bank isolator valves that are normally open, a rig skid return, a rig skid outlet, electrical power, and a rig test outlet. When installing a BOP control system, it is essential to ensure the main accumulator is in a safe area protected from falling debris or gas accumulations during a blowout. All control functions should be operable from the drill floor using a remote control panel. It is recommended to have a second panel in a safe egress area as a last means to close in the well in case the rig is being abandoned. A hydrostatic test should be performed to full working pressure or to 10% below any relief valve in the line, including the testing of downstream pressure reducing and regulating valves to their maximum regulator settings. Additionally, the automatic pump system cutoff devices should be tested to ensure pumps cut off at the maximum system design working pressure. Finally, the system design capacities should be verified at the initial installation and interface of the control system to the BOP stack. The contractor must ensure compliance with all applicable standard regulations and criteria set by local authorities, oil and gas companies, governments, and other governing entities for any drill sites. This includes ensuring that all control system designs meet the strictest requirements of said regulatory bodies. That accumulator precharging remains at the manufacturer's recommended specifications. That the pump system cut on and cut off set points remain at the manufacturer's specifications for the system design. And that the closing time from any control point activation remains within the time limits set by the most stringent regulatory body. APRP 16. Section 16.2 lists the minimum performance and capacity recommendations for surface BOP well drilling control systems. Regular maintenance checks and constant vigilance are necessary to ensure the performance and integrity of any BOP control system. Table 2 outlines the areas for review and maintenance as part of the preventative maintenance schedule. Reviews need to adhere to both the manufacturer's specifications and the requirements of the specific application. Adhering to these checks and maintaining the system as such will help ensure the correct operation and extended lifespan of the BOP control system. Operating accumulators and blowout preventer systems is essential to ensure well control. All pump systems and accumulator banks should remain in use and constantly running. The on-off limits of the pump system should be set properly to avoid the accumulator pressure and fluid capacity being either hugely insufficient or excessively large. The BOP control system nitrogen precharge in all accumulators should be kept within the set limits. Lower precharge will decrease the usable fluid from the accumulator, with no precharge meaning no recoverable fluid. All well control procedures should be adhered to ensure safety. It is essential to measure the nitrogen precharge when no hydraulic pressure is present in the accumulator system. To achieve this, the accumulators must be relieved back into the reservoir. It is advisable to maintain the reservoir approximately half full to provide space for the bleeding of the accumulators without overflowing. Systems in accordance with the APIRP 16 standards feature 25% accumulator bank isolation with individual isolation and bleed valves on each bank. This enables precharges to be verified one bank at a time without shutting down the system. To ensure the optimal operation of the BOP control system, all components should be regularly inspected and, if necessary, lubricated. The nitrogen backup system is a crucial component of the BOP control system. It provides the capacity to shut off blowout preventers if there is a lack of hydraulic power. Generally, it is comprised of a pressure regulator, a safeguard valve, and an automated response system that is triggered if there is a disruption in the rig air pressure, or the option to be switched on from a driller's or remote safe area panel. To activate the nitrogen backup system, the annular regulator must be set to the highest regulated pressure. The manifold regulator bypass valve must be put into the high position, and the two nitrogen bottle valves must be opened. Then, the nitrogen system isolator valve should be opened, and the applicable blowout preventers should be sealed. Following this, the isolator valve should be closed, and the manifold bleed valve should be opened to permit the nitrogen to be gradually drained into the reservoir. Lastly, the annular regulator should be reset. The manifold bypass valve should be put into the low position, and the BOPs must be opened through hydraulic control.